Hello everybody and welcome back to our second tutorial of coding advanced undetectable malware in C. And in this tutorial we're going to start off with creating our main function. So in C, in order to actually create a function, you need to specify which type of function you want or what that function will return. And in this case we're going to create integer or int main. Now, once you create a function, you need to open and close these two brackets the same way we did in Python, just in this case we're not going to specify anything between those two brackets because we're not taking in any parameters. And also in C language there is something to define a function such as these open and close brackets. Now you will notice that this is not something that exists in Python language, but in C this is a part of a function syntax. So you need to open these curly brackets and also close them, and everything you type in between of these brackets will belong to this actual function. So right here we will tab this in so we know what belongs to this function, and we're going to create two variables. One of them is going to be our socket and the other one is going to be our client socket or our target socket in this case. So we are going to make those actual two variables to be an integer. And you will notice also the difference between Python and C, for example, is that in C you need to specify the type of variable that you are creating. So you cannot really just create something like sock and then equals 5. You need to type, for example, integer sock equals 5. Okay, so in this case we're only going to create the variable sock and client underscore socket. And at the end of each line we need to specify dot and colon, otherwise it will not know when the line ended. This is also a part of syntax in C that doesn't belong in Python, for example. So most of you that will come from a high-level programming language will actually forget this most of the time. Keep that in mind. If you run into any error, first of all check all the lines and if they have dot and colon at the end of them. Okay, so the next thing that we're going to create is something that is going to actually receive the bytes from our target. Now, in this case, we're going to store that into char variable or char variable, however you want to call it, and it is going to be called buffer. But that buffer, we need to specify how many actual bytes can it take, and in our case it will be able to take 1024 bytes. And make sure that you add the actual dot and colon. As I said before, everything we actually send to the target and receive for the target will actually be stored into a buffer. So basically this is our server. We will be needing to input our actual commands to the actual server in order to send them to the target, and those commands will be stored in this buffer. So let's continue. The next thing that we're going to need is our response variable. So we're also going to define that with our char actual character variable. So char response, and this one will take a lot more bytes. It will take 18,384 bytes. Now the reason why it is taking a lot of bytes is because some of the responses will be large and we want to make sure that we can fit all of them inside one simple variable. Also, what we need to call in actual C program is the struct library. This is something similar as to classes in actual Python, but in C we need to call something called struct because classes do not exist in C. The struct that we are going to call is sockaddr underscore in, and what we are going to define from this actual struct is server address, so server underscore address, and so comma client address. Now, what we're doing right here is basically we are doing the same thing that we did in our reverse shell in Python, just in a little bit harder syntax and also in a little bit more lines because this is low-level language. So don't worry, this is the same process as in the Python socket programming. Another variable that we are going to need is an integer I to be equal to 0, and you will see in just a second why do we need that. And we also need integer opt value to be equal to 0, or pardon me, to 1. So make sure that you set int I to be equal to 0 and int opt val to be equal to 1. Okay, so the next thing that we're going to need is the length of the client socket. So you will see why do we need this. So let's just define it right here. Just copy paste what I'm doing. As you will see, if you just type socklen underscore t and then client underscore length, you will see that this will go green, or basically depending on your actual terminal it will change colors, and then you will define this actual variable right here. Basically what we did for now is we only created some of the variables that we are going to need, and now we're going to go into coding the actual program, and you will see what all of these variables will actually do and what is their purpose in our server. So let's start off with the most important part, and that is creating the socket object. So we called our own socket sock, therefore we need to define it right here. As it is an integer, we will call it sock equals socket, and in between the brackets we will specify something similar to Python socket programming, which is af_inet, which stands for basically IPv4 connection, and comma sock_stream, which stands for TCP connection. So we're going to run our server over TCP, and this 0 just added at the end for all the other options that we are not going to specify. So we are only interested in these two, IPv4 and TCP connection. And in the next line we can simply just check and set the socket options and see what value it will return, and that's where the actual integer opt_val equals 1 comes in place. So we're going to run an if statement. So if, and in actual C we need to open brackets right now, so if, and then call the function called set sock opt, which is the same name as in Python, and we want to set the socket options for the actual sock that we created. We want to set the same options as in Python reverse shell, so sol_socket, comma, so underscore reuse addr, and we want to actually navigate that to the, and then we use this sign. I'm not really sure how it's called in actual English, but specify this sign and call the integer opt_val variable, and in order to do that you simply just specify this sign and then the name of the variable, so opt_val, and then size of opt_val. And the size of actual function simply just specifies the size of that specific variable in between the brackets right after it. So we need to specify if this socket option is set and the size of and the size of opt value is lesser, and we do that after the actual second bracket, is lesser than 0, then it means that we actually ran into an error. And let's see how we can do that. Since this is an actual if statement, if statements also take in the curly brackets, so you need to open them inside an if statement. So we're going to do something like this, and we're going to print to the screen error setting TCP socket options, exclamation mark, and then backslash, and then n for the new line. Okay, and then dot and comma at the end, and we're going to return 1. So let's go over this one more time. So if this function set socket options on our socket with this actual command specified right here is lesser than 0, that means that this function or this actual if statement returned -1, for example. And if it returned -1, that we're going to print error setting TCP socket options. If it returned anything else, that means that it actually succeeded, and therefore we're going to actually continue with execution of our program. So the best way you can check what this means is simply just going to your Google Chrome and set sock opt in C. You can go right here, set socket options, Linux manual page, return value. So here it is. Upon successful completion, this function will return 0. Otherwise, it will return -1, and it will be an error. Okay, so now you should actually understand a little bit better what this means. So if this returns 0, that means that this function completed successfully. If it doesn't return 0, or in this case if it is lesser than 0 or -1, that means that this function ran into an error, and then we're going to print this and return 1. Okay, so basically now you should understand it. And right now we're going to use the actual server address variable, or a structure that we created from this sockaddr_in, and we are going to define it with different types of actual objects. So first object we're going to define it with is server, so address, and then we are going to see and set all of the different objects to this actual structure. So server address.syn_family will be equal to af_inet. So we're simply just creating the syn family to be equal to IPv4. So right here, another object that we are going to create is server_address.syn_address, and then .s_addr. So once again, server underscore address, which is our structure, dot sin underscore addr dot s underscore addr. And that is simply just the syntax in order to define this. And what we are defining in this actual statement right here is the IP address of our Kali Linux machine. And we can do that with the help of a function called inet underscore addr, and in between these actual brackets, under the double quotes or in between the double quotes, we need to specify the IP address of our actual Kali Linux machine. So let me just save this real quick and type ifconfig in terminal. We can see my IP address is 192.168.1.7. So let's nano back to our server.c. And in between these actual brackets, we need to specify 192.168.1.7. Okay, so that is the actual IP address of our Kali Linux machine defined inside of this right here. And in the actual next object that we're going to define, which is going to be the last object, we are going to define the actual port that we're going to listen for the incoming connections. So in order to do that, we can simply just call the server underscore address dot sin underscore port. And there we need to use a function in order to convert the actual port number. So we are going to use the htons function. And you will see if you simply just, for all of these functions that you basically do not understand, or you have half of understanding of what they do, you can simply just go and type in Google search bar htons in C. And then you will see the actual explanation of that function. As we can see, the library that it belongs to is winsock.h. The htons function takes a 16-bit number in host byte order and returns a 16-bit number in network byte order used in TCP IP networks. So you can see that they are mentioning our AF underscore inet. And you can see the htons function can be used to convert an IP port number in host byte order to the IP port number in network byte order. So it is simply just used for the conversion of the actual port number. And the port number that we are going to use in our case is going to be, for example, let's say 50,004. It doesn't really matter. You can use any actual port that is free. And I just noticed that in the previous line, which is the IP address line, we forgot the dot and column. So make sure that if you haven't specified it, you go back and specify it right there. Basically, that will be about it for this tutorial. We're going to cut it right here. And in the next one, we're going to perform the bind function and the listen function, as well as the accepting function of our target connection. So we're going to perform all of the actual functions that we did in Python programming. Just right now, we're going to see how it looks like in C. Okay, so I will just save it right here, and we will continue coding in the next lecture. So hope I see you there, and take care. Bye.